Hello, my name is Matthew LaFears, and I will be presenting my SPSS dataset cholesterol 1. This was an experimental design including 65 patients with high cholesterol studied over 8 weeks. These patients received one of the following treatments: Lipitor, Zocor, or placebo. In addition, each patient had their age recorded. Total cholesterol was reported for every patient at the beginning of the study at 8 weeks. Efficacy of their cholesterol treatment was assessed by the change from baseline pre-treatment levels in total cholesterol after 8 weeks of treatment. The objective of this trial was to compare the efficacy of the 3 treatments and to determine if there was a relationship between the change in cholesterol values. Research question 1. Are the changes in total cholesterol statistically significant after 8 weeks of treatment? This question will be answered by conducting a paired sample t-test. The paired sample t-test would be conducted in several steps. Paired samples t-test is used to determine whether the mean difference between paired observations is statistically significant different from 0. The participants are either the same individuals tested at 2 time points or under 2 different conditions on the same dependent variable. Alternatively, you could have 2 groups of participants that have been matched or paired on 1 or more characteristics, such as age or gender, and tested on 1 dependent variable. First, we must determine the sample size. The first thing that should be done to determine the sample size is use g-power. We use the following input values. We use a family t-test, statistical test means, difference between 2 dependent means matched pairs, a two-tail test, an effect size 0.4, alpha 0.05, and a power of 0.8. Below, you can see the g-power and test assumptions. As you see on the g-power, an a priori compute required sample size. It was a two-tail test, and it gives us our effect size, our power, as well as our total sample size needed, which was 52. For this study, there was a total of 65 participants. Our test assumption, we would use a normality is tested by running tests on the SBS for our hypothesis. Our hypotheses are post-treatment cholesterol follows the normal distribution, post-treatment cholesterol does not follow the normal distribution, pre-treatment cholesterol follows the normal distribution, and pre-treatment cholesterol does not follow the normal distribution. Normality test. Below you will find the test of normality. In particular, we're looking at the superior Wilks test, post-treatment cholesterol with a significant of 0.081 and a pre-treatment cholesterol at 0.83. Since the sample size is less than 2,000, we use the superior Wilks for both variables. The p-value being greater than 0.01, we fail to reject the null hypothesis and conclude that both post-treatment and pre-treatment cholesterols follow the normal distribution. We prove this by doing a whisker box test or whisker box test and find that there is no outliers, as shown here in our graph below. We see post-treatment cholesterol and pre-treatment cholesterol with no outliers. Statistical analysis. Since all assumptions have been met, we can now conduct a paired sample t-test. We test the mean of changes in total cholesterol after 8 weeks of treatment is equal to 0, or the mean of changes in total cholesterol after 8 weeks of treatment is not 0. Here below is our paired t-test. As you can see, for post-treatment cholesterol, a mean of 186.69 with a standard deviation of 17.344 and a standard error mean of 2.151. For pre-treatment cholesterol, we had 209.38 mean with an N of 65, a standard deviation of 9.949, and a standard error mean of 1.234. Question 1 results. The mean difference between the pre-treatment and post-treatment cholesterol score was negative 22.692. The first table of the SPSS output provided descriptive statistics for both variables. The second table presents the results of the paired sample t-test. From this test, we can see that P was less than 0.011. Since P was less than 0.05, we reject the null hypothesis. Therefore, there are statistically significant changes in total cholesterol after 8 weeks of treatment. Research question 2. Are the mean changes in cholesterol after 8 weeks the same or different for the 3 treatment groups? Research question 2 will be answered by conducting a one-way ANOVA test. The first thing we would be defining a new variable that provides the changes in the cholesterol after 8 weeks. Using compute variable command, we generate the variable change by finding the difference between post-treatment cholesterol and pre-treatment cholesterol. The hypothesis was tested. The mean difference in cholesterol value is the same for each treatment, or there is no difference in the mean difference of the cholesterol value by treatment group. The mean difference of the cholesterol value for at least one treatment is different from the other treatments, or there is a difference in the mean difference cholesterol value by treatment group. First, we should determine the sample size using G-power. We use the following input values. Use the following input values such as test family F, statistical test, and A per E to compute a required sample size. For this test, we used an effect size of 0.45, an alpha of 0.05, a power of 0.8. Below, you will find our G-power ANOVA sample size analysis. It was indicated that a sample size of 51 was needed, and for this study, 65 is appropriate. Test assumptions. Normality. Normality is tested by running a test of normality on SBS. We find change follows the normal distribution or change does not follow normal distribution. To our right, you'll see tests of normality. We look at the superior Wilks significant number as 0.33. Since the sample size is less than 2,000, we use superior Wilks for both variables. The p-value is greater than 0.01, so we fail to reject the null hypothesis and conclude that the chain follows a normal distribution. We prove this by seeing that there is no outliers in our box plot in our change graph. Statistical analysis. Since all the assumptions have been met, we can now conduct a one-way ANOVA test. We test the mean changes in cholesterol after 8 weeks are the same for 3 treatment groups. The mean changes in cholesterol after 8 weeks are different for the 3 treatment groups. To our right, we find our descriptives graph, which shows Lipitor, Zocor, and placebo in a total. This gives us our mean, standard deviation, standard error, lower bound, upper bound, minimum, and maximum for all 3 variables. Test. We perform 2 tests, tests of between subjects and an ANOVA. All the significant numbers in between subjects were 0.000, which was less than p-value less than 0.001. Post hoc tests, multiple comparisons. Dependent variable was change. We did a 2-key HSD. As you can see here for Lipitor, Zocor, placebo, you'll find our significant numbers and our mean differences. Our significant figures varied from 0.492 to 0.00, with a 95% confidence interval for lower bound and upper bound. Question 2, results analysis. The descriptive tables provide very important descriptive statistics, including in, mean, standard deviation, 95% confidence interval, minimum, and maximum. The ANOVA table presents the output of one-way ANOVA on change with respect to the 3 groups. We can see that F is 2,62 equals 43.207, and P was less than 0.001. So we reject the null hypothesis and conclude that the mean changes in cholesterol after 8 weeks are statistically significant, different from the 3 treatment groups. It is important to determine which specific groups are different. This can be achieved by running the 2-key HSD post hoc test. From the multiple comparison table, we can see that there is a statistically significant difference in changes in cholesterol after 8 weeks between Lipitor and placebo, with a p-value less than 0.001, as well as between Zocor and placebo with a p less than 0.001. However, there was no significant difference in changes in cholesterol after 8 weeks between Lipitor and Zocor, the mean difference equal to 4.23 and a p-value equal to 0.492. Below, you'll find our assumptions testing using Levene's test of equity of error variances. This tests the null hypothesis that the error variance of the dependent variable is equal across groups. Thank you for listening to my presentation. I hope you enjoyed it.